Alright, in this tutorial I will show you a few ways how to simulate times of day. So Unity doesn't have a time of day simulation by default, but we can approximate the parameters on the directional light, which simulates our sun, via the rotation. So here I have this model, and let's say this model is in this position in Boston on Washington Street, and it has this orientation which is roughly 45 degrees tilted from the north. So what I'm going to do in order to rotate this out of the north is I create an empty game object, and by the way, you should definitely do this in a separate scene because it's easy to mess things up. I call this position, and I reset its position to 0. Then I'm going to child everything. So I'm going to select everything besides the event system, the XR interaction manager, and the directional light to this position, which now allows me to rotate this 45 degrees, or in this case actually minus 45 degrees. And then we have this orientation. So if we would set the directional light to a rotation around the y-axis of 0, it would come directly from the south, and this rotation around the x-axis would then tell us how high in the sky the sun is standing. So there are websites such as Sun Earth Tools that can give us this position when we mark a point on a map, which I have here for Boston. Let me make this a little bit larger. And then we get the sunrise at around 7 o'clock for this day, 2nd of December, and the sunset for 12 minutes past 4 in the afternoon. So between those times it's day and other times it's night. So let's say I'm interested in the sun at 1 p.m. We have an elevation of 22.64 degrees. So that would be the rotation around the x-axis. And then we have an azimuth. So that's the orientation around the y-axis of 201 degrees. Let's try these two values, approximate, so 23 and 200 in Unity. See what happens. So that would be 22. So we have these long shadows that are typical for the winter time. And then we have a rotation around the y-axis, which is vertical in Unity, of 201. So here we must bear in mind that the angle format here is different. This azimuth actually starts here at 0 in the south, then has 180 degrees up top in the north, and then it continues. So we would want 200, which would then give us a value of y20, and that would then give us relatively well the sun position in Unity. So we have the shadows pretty much exactly as they would be. So that's one way. Another way that is more of an approximation is using a skybox. So a skybox is essentially this environment that Unity offers us here, which has this sun that corresponds to our directional light. And we can change that by using so-called HDRI maps, and they are available on the asset store. So Skybox Series 3 is one you could get. If it's not saying open in Unity, which it likely doesn't for you, then you would just hit this blue bar. It will then become available in your package manager. So Skybox Series 3B, going to copy that, Control C, go into the package manager. In my assets, I'm going to search for that, select it, import it. If I can import it because I have already downloaded, so you would first download it, then import it, which will take a moment. And when this is done, we get the folder Sky Series 3B. To our scene, there's something we can do. We can go into the top view, change to isometric by clicking this little hamburger menu, and save the prior scene, save this as a new scene. Under the scenes folder, call this tutorial Skybox. There's actually one thing we can do to make this model easier to handle since we have rotated it. We can now child this directional light also to the position, and then selecting the position, we can rotate it back 45 degrees, and everything is then going to be straight again with the shadows still correct. Because we have childed the directional light, and if we wanted to, we can now use the elements from that were childed to the position game object and then drag them out again. And then we can delete this position game object. All right, so this makes it easier to handle. Something happened to my wheelchair. I need to push it back into the space. Not sure why that was. But yeah. Now about skyboxes. I have a lighting tab here. If you don't have that, go to Window, Rendering Lighting. That will give you this lighting tab. It may appear somewhere else, but you can drag it next to the inspector. And there we find a tab called Environment that has this default skybox up here and no sun source. So as a sun source, we can drag the directional light in here, and we can now change the skybox material to one of Skybox Series 3B. So this asset comes with a number of different skybox materials. If we select one, for instance, Sky High Fluffy Cloud Field, and we go into the inspector, we see that this is a skybox where you are actually above the clouds, so that doesn't make that much sense. Planetary Earth, let's see how that looks. Here we are also above the Earth. Cloudy morning, let's see how that looks. Yeah, that's better. And this six-sided megasun, well, that could be representative of a sun that sits low in the sky as we have in winter, as we do in this example. So we go into the lighting tab and drag the six-sided megasun into the skybox material. What happens is that this sky is then the new skybox, but we have the sun in the wrong position. So going back to this material, we can change its rotation to roughly match where our sun actually sits, as we see with the shadows. And when we alter the skybox, we also see that it affects our scene lighting. So especially in such evening scenes, it's possible that our spaces get really dark, and the same would be true for spaces with few windows or no windows. It is possible to add lights to our Unity scene by right-clicking. Then there is light, and we have several options: spotlight, point light, and directional light. Directional light we already have. There should only be one, which is the sun, but we can, for instance, add a point light, which will then appear in the hierarchy and has a couple of settings here in the inspector. But let's first drag this point light to a position where it's visible. So let's say here above, close to the ceiling, we would have this point light, and as we see, it's starting to light up the scene. For the purpose of speed, not too many of these point lights should have their shadows active, because they will always be calculated in real time, and that costs us performance in VR. So what we can do is simply under shadow type, where it says soft shadows or hard shadows, tell it to have no shadows. The scene will still be lit, but the shadows will then not be computed in real time. We can also control the range of this light, so how far it's lighting up things. Here it's 10. What happens when we do 2? It's very dim. 5 would start reaching this end of the room. 7 would be better. And we can also control the intensity. So here it's 2. When we change it to 1, it's a little bit dimmer. So depending on how you want to light up your scene with these point lights, you can adjust these settings. Again, it is recommended to use no shadows because that can be a detriment to the performance of the simulation. Once you have a light that is okay, you can also select it, and with Ctrl D you can duplicate it, so you have another light. Using it Ctrl D again to have, let's say, another light down here. And there we would then have some lights when we simulate a later time of day with the methods that I just explained. And that was it for this tutorial.